Okay. Did we talk about this example question last time? No. No? Okay. Let's look at this example question. Actually, this is a pretty an easy one, but we can look at it. So, but did we explain all the equation though? Just remember it as suba, right? We can connect. As we learned in A1, we derived all the four suba equations, and then we just need to relate them to their correspondence in the translational motion, right? Basically, those equations are just rotational format of suba. So they're just our old friends wearing a different clothes on a different day. Okay, let's look at this example here. Find the angular acceleration of a bench grinder's cutting wheel if it reaches 2,500 RPM in 3.5 minutes. What is RPM? What does it represent? Revolutions per minute. So what does revolution means? One full circle. So that means every minute it can rotate 2,500 circles, complete circles, right? So what is its angular acceleration? What can we do? How do we define angular? How do we define angular acceleration? We need to use this to find angular acceleration. So in 3.5, it will reach this much, right? It starts from 0, so omega I, its original or initial angular velocity is 0 rad per second, right? And the final velocity is how much? 2,500, right?
5,000
Can we directly use 2,500? What do we need to do? We need to convert it, right? Because the unit that we should use is rad per second rather than revolution per minute, right? So omega f equal to 2,500. So how many rads? How much rads in one revolution? 2 pi. So we times 1 ReV 2 pi rads. And how many minutes? In seconds. 60 seconds, 1 minute, right? So we can cancel out. Minute cancel out. Revolution cancel out. We get 5,000 pi over 60. And that's going to give you how much? Calculate it out. 261.8 rad per second. Okay? And then alpha is simply just delta omega over t, which is 261.8 minus 0 divided by 3.5, which you're going to get
74.7.80.
0.8 rad per second squared. Let's check answer. 74.8. 75. Very good. So the first one is easy. We just need to apply this equation, similar in suba. Second one, find the angle through which the cutting wheel rotates during this acceleration. So we've already found, what do we know? We know omega I, 0, omega F is 260 something? 61. And the alpha is 75. Time is 3.5. So we're looking for angle. What equation to use? Basically anything, right? We can use this one, or the other one could be omega F squared equal to omega I squared plus 2a theta, or delta theta. Alright, apply any one of them, and then we can figure out. During this time, the angle that it has rotated through is 460 rad. 460 rad. Okay? And if we want to know how many circles it have complete, what do we do with it? We divide it by 2? 2 pi to get the number of the revolutions, right? Okay. Then find the tangential acceleration of the edge. So we already know alpha equal to 75 rad per second squared, right? How do we find the tangential acceleration? So A tangential should equal to R times alpha, right? R is here 0.05. Don't forget to convert it into meter first. And then times 75 rad per second, you're gonna get per second squared, you're gonna get the tangential acceleration, which is 3.8 meter per second squared. 3.8 meter per second squared. We're good? Okay. Why here, after acceleration, after the completion of the acceleration, alpha is 0? Why? It stops? So when it reaches this, after 3.5 seconds, it stops rotating?
It keeps rotating, but don't change.
It keeps rotating at constant rate, right? It's not rotating faster and faster. It reaches its maximum or operation speed, rotating speed. Does it make sense? Okay. Alright, so then in that case, tangential acceleration is also going to be 0. Alright? Okay. Alright. Find the net acceleration of the edge of phi this while at the time equal to 0.08. Let's do this together. Okay. Instead of me directly walking you guys through, I'm gonna give you 2 minutes to work on it, and then we're going to ask you for the answer and see if you can get it correctly. Fast recovery. Chloe, okay. Well, I don't ban you to use electronic devices on my class, but I highly do not recommend that you directly, whenever I pose a question, that you directly ask help from AI, okay? Because if you directly get answers from AI, there's no thinking process, and you might get answers right away, but it's not gonna be helpful, especially when you're doing the exams, there's no extra sources that you can utilize, right? So utilize it as a practice on class. You may use AI afterwards at home to help you get quicker ideas, but on class, let's just utilize the time to practice your thinking process. Okay, let's see. Vincent, what do you think? What can we do? Sure, because we're finding the net acceleration, we know that A net should equal to root of A tangential square plus AC square, right? That means we need to find tangential and centripetal acceleration when time is 0.08. Okay, first step, correct. All right, then how are we gonna find those two when t equals to 0.08? Let's look at tangential first. So previously, we already have the information of omega I, we solve it 0, omega f is 261, something like that. R5 equal to 75. This is going to be useful information for us, right? And the time in this case is 0.08. Okay, so what is A tangential at 0.08? What equation should you use, Nancy? Times angular acceleration, okay. 0.05 times 75, you get 3.75 meter per second squared. What about AC? How do we find AC here?
AC is radius times angular velocities.
Very good. We use AC equals to radius times angular velocity squared. Now, which value should we use for this one? Is it a constant? Omega here? Is it a constant? No. Why? Why not constant?
Because you change your.
Why is omega here not a constant? It has angular acceleration. We already said here, right? So we need to find out at t equal to this much, what is omega? Basically, this omega is the omega at t equal to 0.08, which is omega f, right? It's just omega t equal to 0.08 should be equal to omega t equal to 0 plus a times t, alpha times t, right? So then we plug in the values, 0.05, what should be this omega? 75 times 0.08, which is going to give you 6. Okay, so 6. Don't forget square. So you got AC equal to how much? 1.8 meter per second squared, right? And then you plug in this value, you can calculate the A net, right? So what's the final answer for A net? 4.96. Did you get the same AT and AC? Okay, so let's check answer. 4.916. Okay, let's check answer. So, first of all, we get a tangential 3.8, that is correct. Then we get AC, which is 1.9. And so, final answer A net is 4.2. 4.16, that is correct. Very good. That's how we solve it. Okay, that's how we solve it. All right, don't forget. Look at here. The green one is the A net. The red one is centripetal acceleration. A blue one is A tangential. Okay, let me ask you one more time. What is the purpose, or what does AT do? AT change the magnitude of the rotating speed, right? Basically, AT will cause you spin faster and faster. What does AC do? It changes the direction so that it will keep rotating, right? It changes the direction. Okay, very good. All right. Then after this one, let's look at this here. So if the sum of the forces acting on the body is 0, it will be in translational equilibrium, right? Which means it's not moving. But what about this, right? Right now, these two forces, their length is the same, right? So same magnitude, and they're also in what direction? Opposite direction. So can we say that it's translational equilibrium? Is the sum of the forces 0 here for the second one? Is the sum of forces 0?
Yes.
Then it is translational equilibrium. But it is not absolute equilibrium. Why?
Because
It will rotate, so it's not in rotational equilibrium. Why is it not in rotational equilibrium?
net torque is not net.
Net torque is not 0. Because if you take any point in this bar, let's say this point, if you take this point, does this force has torque at this point? No, because perpendicular distance is 0. But does this force have a torque on this one? Clockwise or anti-clockwise? Clockwise, so this way, right? Okay, even if you don't take this point, any point is the same. Let's say you take this point, then does this force acting on this point has a torque? No, but what about this one? Has. Clockwise or anti-clockwise? Still clockwise, so it's still gonna rotate this way. No matter which point you pick, right? Even if you take this point, sure, this one here will have a anti-clockwise torque, right? This one will have a clockwise torque. Then would it spin clockwise or anti-clockwise? Still clockwise. Why? Why is this one torque is greater? R is greater, right? So this one, the torque here is going to be greater. This torque is smaller. So overall, it's still going to spin this way because its perpendicular distance is 2 times of this one. Right? So, right, it's difficult. So translational equilibrium, basically, as long as net force is 0, right, we can make sure that the center of mass does not move, right? There's no movement, but still, even if it's in translational equilibrium, it can rotate about any point, about its center of mass, right? So it is not in rotational equilibrium. Any questions? No. Okay. All right. So let's look at it. How can we do? If we have a point mass and we directly put a force on it, then we know that this force is going to displace it. It's going to accelerate this point mass, right? We can apply F equal to ma, right? If the force is acting on a rigid body, which means we cannot ignore the shape, we cannot ignore the size, the volume. However, if the force is acting on the center of mass, then it's still the same effect as the previous one, right? This force is going to accelerate the object. Okay, there's no rotational motion. Just like this ball here, if I move it, if I apply the force right through the center of mass, it will not rotate but move translationally. However, if the force that I apply is not through the center of mass, let's say a little bit go that way, it will rotate, right? So that's what it means. That's what it means. That's the third one. If the force is not towards the center of mass, then because you see this force will have a perpendicular distance from the center of mass, which will create a what? Torque. So torque will make this thing to spin clockwise like that. Alright? So it's more complex than the previous two. In NYP, we only discussed the situation here, which means we only consider the translational motion, but in DP, we also need to take the rotational motion into consideration now. Okay? So it could be that what could be the hardest question? That the object is rotating and moving at the same time, right? So you need to think about this question from two perspectives. If we have a fixed axis, then we know that it will just purely rotate. Will it move? Will it translate? No, it will not translate, but it will rotate, right? So among all those four, the third situation is most complex, right? Any questions? Okay, so let's see. Here's the thing, right? If you apply a force on the center mass of an object, what the force does is just to translate it. It does not rotate it, right? It just displaces this thing from this location to this location. But you see, it's horizontal, and here it's still horizontal. However, if the force that you apply is not through the center mass, and the center mass is being fixed, then the force, what it does is it will create a torque that spins or turns the object. For example, right? If I fix here and I apply force here, it will go like this, right? But if I don't fix here, but I apply a force, let's say, apparently, am I applying the force to the center mass here? No, because it rotates, right? So, still no, still no, still no. It's difficult to find the center mass for this thing. Anyway, I'll use this one. All right. That's about the center mass, right? Okay, you can tell if it rotates. So, this should be here. That's the thing. Torque is the IB name for moment. But I would more likely to, me personally would like to say moment is more like static, right? When MIP we learn about moment because it's all in equilibrium situation. And torque is more dynamic because we're literally looking at things that starts to spin now, right? So, but in the essence, the way to calculate it is the same. Okay? Any questions? Alright. So, now we use this symbol to represent torque. Okay? Torque is the turn effect, which is the force multiplied by the perpendicular distance from the pivot. Usually is the pivot. Okay, from the point. Usually it's a pivot. Okay? That's exactly how we define moment in MIP, right? Okay, so, but what if there's an angle? We times sine theta, Okay, so if there's more than one torque, then we just need to add them up, take their direction into consideration, right? So if we add those two, because there are different directions, we need to set one. For example, if you pick clockwise as positive FR, then anti-clockwise should be negative FR over 2 in this case, right? Any questions? Okay. All right. Good. So let's look at an example here. Okay, a bridge with 2 supports has a truck partially across it. Draw the diagram and add the forces acting on the horizontal span of the bridge. Marvin, can you come to the whiteboard and draw the forces diagram? And everybody else, draw it on your notebook. Read the question carefully, because you don't want to draw forces for the wrong object. If you draw the forces, no, you need to come to the whiteboard to draw it. If you draw the forces on the wrong object, you lose every point. Okay? When you do the question, make sure you read the question carefully. What is your study object here?
Force acting on this object
Okay, so you want to draw the forces for what?
for the bridge.
Yes, so draw the forces that acting on the bridge. Don't draw the force of the car. You're not studying the car, right? The question is asking you to analyze the forces on the bridge, the span of the bridge, not the car. Almost there. Almost there.
还差这个车的。
Almost there. Almost there. Not sure? Okay. Alright, can you come to the board? Yeah.
这个是老师。我也买的。老师不是我包。
Can you explain each forces? What is this R1? What thing gives the bridge the force? Okay, the supporting force provided by the support, right? Okay, so that's R1, the supporting force provided by this thing here. What is this force? From the car. The car will press down on the bridge, right? So car exerted force on the bridge. What is this force? Gravity of what? Gravity of the earth? So a lot of you do not know this. So this bridge has no gravity, has no weight at all. It just floats there, right? Anti-gravity world now we're living in a.
Good.
Okay. And what about the last one here? Also a supporting force from another support here, right? Okay, thank you very much. Okay, some tiny details to look at. First of all, when you draw this R1, because the force is provided by this, right? So you need to make sure it's lined up with the center of this thing, right? So go here. And this one, the force acting on the bridge, because it's due to the gravity of the car. It's the car's gravity that's pressing down on the bridge. So you make sure this force acting on the bridge, it does not directly touch the thing because it's acting on the bridge, not acting on the car. But because it's due to the force of gravity of the car, it needs to line up of the center of the mass of the car, right? And this one, since it's the bridge's own gravity, it needs to come from the center of mass of the bridge. And this one here, it has a slight problem because it does not line up with the support here, right? So you need to move it a little bit here so that it lines up to the support, R2, right? Okay, that's the forces diagram for this bridge. Did I make it clear? A lot of you did not draw this, okay? A lot of you did not draw this, which means your bridge has no gravity, has no weight, which is impossible, yes?
What if you draw the gravity, the weight on the two sides?
What do you mean?
Like the weight, it's on the.
It's not allowed because gravity is always acting on the center of mass. Because each little part, actually, each part has its own gravity, right? The forces, because you can divide the bridge into infinity parts of smaller parts, right? Each smaller part has its own gravity, but we don't have time to draw all the gravities for each part. So we just use a resultant force to represent all of the gravitational force. And this gravitational force must act on the center mass of the object. Okay, so you cannot draw it like that, okay? Alright, so that's the correct way of drawing it. Fa is the supporting force from this thing. Fb is the supporting force from this. Weight of the bridge, of course, acting on the center of mass of the bridge. And W truck is actually the pressing down force due to the weight of the truck. Right? It's not a wise name to name this force as W truck because it's not the weight of the truck. It is the pressing force acting on the bridge due to the weight of the truck. Does that make sense? Okay, so this name is not named ideally. Okay, now think about this. When this car is at this position of the bridge, is the bridge translationally moving? Is the bridge rotating? So that means this bridge, even though with the car driving through it on it, it is in absolute equilibrium, which means two conditions must hold true for this situation. What are the two conditions here? Right? And two, which means from A we can get Fa plus Fb should equal to weight of truck plus weight of bridge. Does that make sense? What about the second one? How can we do the second one?
Torque A equals to torque B.
Okay. Hiya.
Torque A equals to torque F truck plus torque B.
Well, isn't the simplest way is just torque A plus torque B plus torque truck plus torque bridge should equal to 0? If you, yeah, right, torque net, you just plus everything. But the point is, you need to identify which are clockwise, which are anti-clockwise. But you couldn't do that if you don't pick a pivot point, right? So you, for yourself, must pick a pivot point first. And you can literally pick any point as the pivot point. However, there is tricks to pick the correct or ideal pivot point that makes the question much easier. Number one, the most special point that you should consider about is the center of mass, sure, if we consider center of mass. Okay, then Fa to center of mass will create a clockwise or anti-clockwise? Clockwise, so this is C. And truck will create a anti-clockwise. W bridge, nothing. What about this one? Anti-clockwise, alright? Anti-clockwise. So you want to make sure clockwise and anti-clockwise cancel out. So that means in this case should be torque A in magnitude should equal to torque of truck plus torque of B. Does that make sense? Or sometimes if you don't know a force, let's say if you don't know force of A, you know the weight of truck, you know weight of bridge, right? You don't know it. It's best that you don't need to consider it. So how can we make that, what can we do so that we don't have to consider the torque of A?
Put the pivot point.
We put the pivot, we take the point about this point so that it does not create any torque about this point. We know the force of truck, we know the force of the bridge. If we know the force of B, then we can solve it, right? So. All right. Okay. Now, let's do this, all right? We know that there is a third way across the bridge of 30 meters bridge, okay? So weight of truck is 20,000 Newton, weight of the bridge is 50,000 Newton. Find A and F. How do you find A and F? Solve it. I'll give you 3 minutes to do it. Are we all math HR here? We're all math HR, right? Okay, good.
我刚刚10，所以我刚刚算4。
Is it more like literature or more biology? More literature?
10，刚刚好10。
自己的计算器吗？
拉下来。
Finished?
好了好了。
Okay, Luke, what is your answer? FA equals
38000。
38,000 Newton. What about FB?
3万。
32,000 Newton. Thomas, is your answer the same? Lucas, is your answer the same? No?
It's asking for translation.
For FA and FB.
不是。What do you say?
What's your answer? Did you got any answers?
No, I don't think I know.
Jason, what's your answer? Not yet. Marvin, what's your answer? Indy, what's your answer?
I think I misunderstood the question.
Okay.
38333.3。31666.7。
Girls, any answers? Same? Okay. Same. Alright, then 5 minutes break and then we will talk about this one.
不是你们干什么？
你们有那个 any subjects 已经 like this week is going to take the period quiz or next week?
No，只有下一个。
哪个 subject 下周考？
没有。
没有啊
我 English 下周考。
？English 下周就考了是吧？周几？Okay.
Really?
But don't worry guys, because week 5 is national holiday.
Oh yeah.
所以你们有一个 whole national holiday to review for physics. Because 我们还要，我们下周要把 A3 讲完嘛，对吧？但是下周就 national holiday 了，所以你们有一个星期的时间去
Our
review.
break is after national holiday.
Looks like it.
Oh,
Looks like it.
以前别人也没过。对。
However, HR only can be happening before national holiday. H only A4.
Only
Is-
A4?
Are we taking two tests? Or
Okay,
is
that's
it
not
like
able to
each
do
one?
the top.
Or
We
is it
could
all-
separate HL from SL. So which means A4, because A4 this week, I think I can finish them. But we'll have to see. If I didn't finish A4 today, then A4 would be after national holiday as well. If I finish it today, then A4 could be next Monday.
Next
Last
Monday.
question, last question.
Or
Last
wait,
question.
next Monday. Next Monday. Right before the national holiday.
So I'm getting curious.
But don't worry, anyway. Okay, so let's look at this question
你要装
here.
傻的。
Alright, so what do we know about it? We know that those two forces, this one is 20,000. This one is 50,000. Right? So we know that because the bridge is not moving, so resultant force must be 0, which means FA plus FB must equal to these two forces to cancel out. So we know that FA plus FB must equal to 70,000. Right? So let's check. Is this gonna get you 70,000?
Yes.
Yes. So your answer should be at least a combination of sum of 70,000. That's the first thing. Second thing, we have two unknowns because we want to find out FA and FB. Only one equation is not enough to solve for two unknowns, right? You must to have two equations to solve for two unknowns. So the second condition is rotational equilibrium, which means net torque should be 0. And again, because we don't know any of the forces, is it wise to pick the center of mass as your pivot point? No, you're canceling out your half of your known conditions, right? That's not good. You don't want to cancel out your condition. You want to cancel out the unknown. So you either take A or point B as your pivot. Right? Let's say we take point A as your pivot. Then we know that F track is going to give you a clockwise, right? F bridge will give you clockwise. FB will give you anti-clockwise. So basically you're going to get TB, torque B should be equal to torque track plus torque bridge, right? So how do we calculate torque B? FB times the distance from FB to point A, right? What is the distance? 30 meters. Now, what about F track? That's 20,000 times. How do you know it's 10? 1/3 of the way, right? So, which means this is the 1/3 of the whole length, which is 1/3 times 30, which is 10. What about the bridge here?
50,000.
Should be 50,000 times
50.
why 15?
Because middle.
Because it's center of mass. Center of mass is in the middle. And then you can solve for FB, right? FB solved, you get 32,000, right? And then you use 70,000 minus 32,000 to get 38,000, right? Is everything clear? So first of all, we solve for FB, which gives you 32,000. And then we use 70,000 minus FB to get FA. Or a dumb way, you use this again, but of course you prefer plus minus rather than multiply and divide, right? So rather than use the moment again to take moment about FB, we would like to just use the net force equal to 0 so that FA is 38,000, right? This is a much faster and easier way to do it, rather than you take moments about 2 points. Does that make sense? We're good? Okay. Right. How about this one? calculate the upward reaction force on each end of the bridge with the truck of a pulling trailer. I'll give you 4 minutes, and then you're gonna give me the answers. SL period quiz is definitely after the holiday, the national holiday. HL, I think we should be able to do it before the holiday. Like on the 28th, September 28th. Oh, 28th is sports day 是吧？行啊，那就我看看。如果放在第7周 week 7，October 13th 的话，
这他也是属于
October 我
不是
们
第5则变成7吗？
放到 OK， 然后10月9号考试， 10月13、14考试，也可以。International holidays，好吗？这样你们 less stressful，好吗？
但是他们得玩就烂掉了，
Okay.
准备烂掉。
All right. So you guys finished?
Yes.
All right. So Jessica, what is your answer?
I got
Let's say this is FA and this here is FB. Okay. What about FB?
12,633.
Okay. All right. Let's see. So first of all, we take moments. You get force A is 12.3 kilonewton, 12.3, about that, kilonewton. And the second force is 9.7 kilonewton, 9.7 kilonewton, about that. Okay, everybody got the same answer?
Check it out now.
Why not?
It should, because here, if you look at the numbers that's been given, right?
Then it should be 12 kilonewtons and
12 kilonewton, 10 kilonewton. This one here is not like 不是非常的严谨这个 question, okay? 一般来讲，像这种，它的精度应该是要3.5或者是给4.0、8.0，然后10 point 牵牛 ，okay? So this is not a very well designed question, but anyway, okay. All right. Let's look at this question. The sign is exactly like the one in figure 10.13, which is here. The sign, which is this sign, has a mass of 50 kilogram, and the bar is 10 kilogram. The bar is 3 meter long in length, and wire is attached 50 centimeters from the end. That makes an angle of 45 degrees with the bar. Calculate A, B, and C.
A 是哪个 B 是哪个 C 是哪个？
I'll give you 5 minutes. Just one more example question, and then we can skip this time. Recording. Okay. Lucas, why not share your answers with us? What did you get?
The tension force should be equal to 500 newtons.
500 newtons. Okay. So, did you got B and C as well?
Yes.
R is
350 newtons.
350, and F is?
235.
Anybody got the same answers as Lucas? No? Okay, first of all, let's look at this question together. You want to find out the tension force of the wire, right? What do we know? What do we know? So we know that this sign has a mass of 50 kg, right? So this thing itself has a weight of 500 newton, right? Let's say W sign is 500 newton. We're good? Okay, and the bar is 10 kg. So bar itself has a weight of bar, which is how much? 100 newton, right? Okay, the bar is 3 meters long, and the wire is attached 50 centimeters from the end. So I suppose this should be 50 centimeter, which is 0.5 meter. It cannot be this one, right? Because apparently your strain is left hand side of the center mass. 45 angle, okay? So first of all, we need to know the tension of the wire. The this normal force here, and the upward force here, and T here. Okay? So if that's the case, because we don't know R and F at all, right? And is there any way that we can exclude those two forces?
Yes.
What way?
Setting the axis at that point.
We take this points, we take moments about this points, right? Because both of the force passing through this point. So F has no torque at this point. R has no torque at this point, right? So for question A, take torque about point, let's call that point of A, about A, okay? If we take torque about A, then the only force that we should consider is the two gravitational force and the tension force. Gravitational force we all know, so you can directly calculate tension force. Does that make sense? Okay, so then the torque of T about A should equal to the torque of this two, because the center mass of this object and center mass of the bar is along the same vertical line. So you can directly add them up, right? So then we get torque of the T should equal to torque of W1 plus W2. Does that make sense? Torque of the T should equal to T itself times, what's the perpendicular distance from T to point A? Or in this case, can we just use FD sine theta?
Yes.
Because d sine theta is the perpendicular distance, right? So then, just capital T times the distance here to here should be 2.5, right? 3 meter long, 0.5 meters. So T times 2.5 times sine theta, which is 45 degrees, right? Should equal to the torque of W1 and 2 together. W1 and 2 together is 600 Newton, right? Times 1.5, right? 1.5. From this point to this point. We're okay? Alright. Then let me use a different color. Or let me erase all of those. So you're going to get T times 2.5 times sine 45 degree is basically divided by root 2, right? Should equal to 600 times 1.5. So you solve for T. Then T should equal to 509. 500, that's...
I used the 9.81 as acceleration.
Yeah. Okay, no problem then. 9.81, 600. Okay, cool. And then, after we know the T, how can we solve for R and F? We know T equal to 509, right? How can we find R and F?
F equals to, you said pivot point and tension.
In this case, we should decompose tension, right? So we can decompose it into this direction, tension X, and this direction, tension Y, right? Because it's 45 degrees, so Ty should equal to Tx, right? So Ty equal to Tx equal to just T over root 2, which is going to give you how much? 600 and 360, about 360, right? Okay, then we can remove this T. So what force do we have? We have, in this case, we need to look at in two directions. Let's look at Y direction first. in y direction, we have ty going up. We have going up and going down. Going up, we have ty. And the f, right? F is going up. Ty is going up, right? What about going down?
600.
Going down, W1 plus W2, right? So that means Ty plus F should equal to W1 plus W2, which is 600. Ty is this much plus F should equal to that, so F should equal to 240-ish. So this is about correct. Okay, and then similarly, if we look at x direction, in x direction, there are only two forces, right? So this direction, to the left, we have R. To the right, we have Tx. So R is just Tx, which is 330-ish. So let's check answer. You have 330 and 240. Everything clear? Okay. We're good? Alright. If you have questions, ask questions. Okay. Let's move on. So now we understand a torque is just a force that can cause a rotation about the pivot point. And let's consider this. Okay, consider a door as viewed from above. If we open the door like that and close it like that, right, the location of the force and its size will determine how easily which door will open, right? If you still remember from grade 9, I asked you to open the door, right? You push different places. Do we ask Alexander and who? You? Okay. Alright, so F0 here is acting on the fringe, F1 and F2. Which force is the smallest in terms of opening the door? F0 is smallest?
All force.
F2. F2 is the easiest, right? Why? Because it's further away from the rotational axis, right? Okay, since the torque, the amount of torque that you need to open the door is the same. The longer the perpendicular distance, the smaller the force required, right? Any questions for me? No? Okay, easy. But what if there's angle? So those three angles, angle 1, angle 2, and angle 3. Which angle is easiest to open the door?
1.
Why?
90 is 1.
If you have angle 1, then the perpendicular distance is just R, right? If you have angle 2, which is this angle theta 2, you apply your force like that. Then your perpendicular distance, you have to extend this, and then your perpendicular distance is this, right? This one is clearly shorter than this one here, because in this right triangle, this is the hypotenuse, right? Okay. Right, so here we go is the torque equal to FR sine theta, where theta is the angle between forces and the radius, okay? And torque is a vector because it has clockwise and anti-clockwise or counterclockwise direction. And R is just the distance that the force is from the pivot to that point. You times sine theta, then it's no longer required perpendicular distance, right? Because R sine theta is the perpendicular distance. So R itself is no longer perpendicular distance here. Note that the torque uses the value of Newton meters, okay? Newton meters. And the work done is also calculated by forces times distance, which is equivalent to joules. However, you don't want to mix up between energy and torque because that's two totally different concepts in physics. It just happened to be that they share they use the similar formula to calculate it, but the physical meaning behind it are totally two different stuff. Okay, one is about the turning effect, the other is about energy. Okay, so never use joules for torque. If I ever saw a capital J in calculating torque, wrong, wrong, wrong. Points low, low, low. You will fail, fail, fail. Okay. All right. Example too simple. You just need to apply this, do that. So we're not gonna waste time. Let's look at moment arm or the lever arm. Okay. Consider a disc that is free to rotate about its center like that. And the application of the identical force to the disc edge at point A, B, C, and D will produce very different outcomes. Let's look at this A, B, C, and D. Okay. Let's think about C first. Okay. We say that the disk is free to rotate about its center, but let's say it's been fixed. The center is being fixed. So does C have any impact on the disk? No. Right? Because what does B do? It will rotate in which direction? Anti-clockwise. What about D? Clockwise. What about A? What's the difference between A and B? Is FA stronger?
Yes.
FA stronger?
No. Why not?
What is stronger?
FA.
The torque produced by FA is stronger. The force is the same because they're the same length, right? Identical forces, and it said it's identical, right? The force is the same, but the torque it produced is not the same. Why is A produce a stronger torque? Because the distance, the perpendicular distance is longer, right? This one, only this. This one has this much longer, right? Okay. Or, if you wish, we can all use R, but we need to times sine theta. This one here has a theta of 90 degrees, right? So sine theta equals 1. This one here, sine theta is definitely smaller than 1. This one, sine theta is 0. This one, sine theta also smaller than 1. So A has the greatest effect, right? We're good? Okay, so we define the moment arm or the lever arm as the component of R that is perpendicular to F. So in this case, the lever arm is this distance here. This green here is the lever arm. Okay? And it turns out that the component is just R sine theta, and that the forces times the lever arm is the torque, right? So what is moment R or lever arm? Just R sine theta. Just R sine theta. Theta is the angle between R and F. Any questions? Okay. Right, so translational equilibrium, as we already talked about, rotational equilibrium, net torque is 0. Okay. All right. Any questions? If net force is 0, does that mean that it's not rotating? Not necessarily. Because F net force is 0 only determines that it's not moving translationally. but we don't know if it's gonna rotating or not, because we need to know the net torque information, right? Alright, so we have, those are pretty similar, easy stuff. Easy. So, 这些都是我们讲过的。Okay, this one looks a little bit more challenge, but still the same thing. Let's spend so oh, by the way, just one thing. For the hinge here that attached to the wall, okay? The forces that it provides can be decomposed into two directions. That's the only trick, okay? That's the only trick. It doesn't necessarily give you a perpendicular force like that, okay? So that's the reason why when you see this one here, it has horizontal force and vertical force. So the hinge, as long as you saw a hinge attached to the wall, always think about, okay, there could be forces that decompose into two, both vertical and horizontal. Because if not, it will never be able to reach equilibrium, because you're missing something there. So just one trick here to notice. Okay. All right. So, do you guys wanna？其实都差不多，我觉得没必要做这么多，一道题，对吧？这道题不就跟那个 tension 一样的吗？就是 you take moments about this point, cancel out everything to get the t, and then you decompose the t, right? Same trick. Same thing here, so don't waste time. The latter problem, 可以做一做，这个可以做，来吧。Here no friction, here with friction. Ladder 是梯子。
你这ladder。
I'll give you 5 minutes. Do you still remember how to calculate friction? We already learned it last week in A2, right? F equal to mu times N. What is N? Normal force, right? Oops. Okay. Alright, that's it for this week. That means we didn't finish everything today.